Hello, everybody. Welcome to the second class of SROK CMDB's uh, educational program on chemistry revision classes. So today we'll be doing the first chapter of a chemistry textbook of the syllabus periodic table. Two disclaimers before we go into this video. So the first one is that I am also a student like you, okay? So I could make mistakes, so do not blame me for it. Any lost marks, any risk, SROK, CMDP will not take responsibility for any lost marks. And second disclaimer is that do not use these videos as your only study material, okay? The reading, I still believe that reading is the most important way we can learn. And this could just be like if you don't have any motivation or you just want to have like brief through of the chapters, you can just use these videos. But and yes, those are the disclaimers, and if you agree to those, we can get into this lecture. So, this is the overview of today's classes, and yes, it's a good way to get started with the class because you uh, you as viewers will have an idea of what we'll be doing today. So, if you're not interested, uh, you can skip the parts which you don't want, which you think you don't want to, or bet already really well. Yeah. So, but I would request all of you to see the whole video. So yes, so first we'll be discussing about periodic table, the some of the properties of it, special characteristics, and um, what it's based on. And then second, we'll be discussing about the periodic properties: atomic size, metallic and non-metallic character, uh, ionic ionization energy, and electron gain enthalpy or electron affinity and electronegativity. Yes. Yes. So as you can see over here is a periodic table. It's the basis of chemistry. We study reactions between these many elements and their properties, and physical and chemical properties, the reactions between them. Um, this is what basic chemistry is. Basically, chemistry is. So in the periodic table, as you can see over here, we have seven periods. It looks like some Australia shape. You can remember it like that. But I think in the out of syllabus lecture I gave last before this, um, that's a better way to remember it. And these are again two two other. I mean, they are the two lanthanide series and actinide series. They belong to the third group, sixth and seventh period. So these are not considered eight and nine. We just cannot fit the these two periods. I mean, these two periods into where they belong because otherwise it will distort the shape of the periodic table. So yes, so today we'll just be discussing like basically what this periodic table is. So the seven periods we have spoke about the seven periods, and then there are 18 groups also, as you can see. You can count these are two. For those of you who were there last time, remember S can accommodate two, and then D can accommodate 10, and P can accommodate six. So there are basically 2 plus 10 plus a 6, which is 18 groups. And then this and all comes under F shell, which is 14 electrons, which can accommodate 14 electrons. But yes, so 7 and 18, that's something. But in our syllabus, we just have to learn all of the elements up to 20, which is calcium. You don't have to learn the transition element parts and inner transition elements, basically. So, um, first, we'll just be discussing how this, I mean, on what basis this periodic table has been made. So, um, the periodic table of elements, the modern periodic table is based. upon the periodicity, which is with the modern periodic law, which states that uh, periodic properties are functions of um, the atomic number of elements. So why is that so? So we know that in an unreacted state, the number of protons is equal to number of electrons, and we also have studied over the past few years that chemical reactions depend on number of valence electrons, because if, for example, like organic chemistry is only happening because carbon has four valence electrons, and because if it has any other three or two or something like that, then it can form ionic, or six or seven, it can form ionic and covalent. I mean, ionic bonds, and then organic chemistry won't be profound. So, as we have learned, so that is the reason why, that is the basis. So, atomic number. So, all of them are arranged on basis of atomic number, and we can see some properties here. So, while because we know that the atomic number increases, I mean, the from left side to right, as we go from left side of the periodic table to the right side, hydrogen has one electron, then helium has two electrons. So basically, in this periodic table, um, we can say that number of valence electrons increase across period, and then we know that lithium has, yeah. So then and then number of shells increase when we go down a group. So um, this periodic table can be can help us in determining the number of by knowing the position of an element, we can determine the number of electrons and the number of valence electrons and the valence shell up to the 20th element. But after that, it's not that simple, it gets more complicated. That's why we're not doing it. So for example, we take beryllium over here. Beryllium is the, it's part of the second group and second period, which means that it will have uh, two valence electrons, and the two valence electrons will be in the second shell of beryllium. So yes, so the two valence electrons of beryllium will be on the second shell. This is what it effectively means. And here's a here's the nucleus. Yeah. And then if we take any other element, let's say sulfur. Sulfur is in the 16th group, but we know that there's no, I mean, usually we subtract the transition element group. So 16 minus 10 will get 6. So sulfur has 6 valence electrons by knowing it's 1, 2, 3, 4, 5, 6. Yeah, sulfur has 6 valence electrons, and then it's in the third period, as you can see. So it has the valence electrons are in the third shell. And then here's the nucleus. So you can see it. And then these both shells are completely filled. And over here also it's completely filled. So this is for Bohr's atomic model. This is how the periodic table, we can easily arrange the electrons. I mean, we can easily, using knowing the position of an element, we can derive, we can come to know of its structure. So next, okay, now we'll discuss about the groups and periods and some properties of the elements. So first, group elements are known as alkali metal, alkali metals, because they form basic oxides. And when the scientists found these elements, and they all form basic oxides, so they named it alkali metals. The last, second last, I mean the second group elements are known as alkaline earth metals, because they're found on Earth's crust, like magnesium, calcium. Um, they are all found on Earth's crust. And then and they're also alkaline in nature. The Yeah, and then some other groups are the oxygen group is known as chalcogens. And then this group 18 group 17 is very important. Group 17 is very important. It's called as halogens, and they just have less electron than group 18 elements or group 0 elements known as noble gases. Um, yes. So then in yeah, what else? Yes. So these are the some of the names and the alkali metals. The alkali metals halogens are very important, and the noble gases are also like an important group for the syllabus. So now we'll be looking at some of the classification of the elements, like uh, for the names given to particular some sets of elements. So the second and the first one is bridge elements. Yeah. So bridge elements are just second period element and third second period and diagonally the third period element. So lithium, magnesium, beryllium, aluminium, boron, silicon, carbon, phosphorus, nitrogen, sulfur, oxygen, fluorine, and we don't generally consider fluorine an organ, but this is due to the fact that some properties of elements, they increase across the group and decrease across the period. So, um, for example, if you take sodium and some properties, they will increase when you go above, and then they will decrease when you go above, and they will also decrease when you go towards the right side. So lithium and magnesium are more likely to have some properties common. Same with, let's say, magnesium. When you go towards the right, some property might decrease or increase, and when you go up, also it might decrease or increase, or decrease or increase. So beryllium and magnesium. When we discuss some properties like atomic radius, we can, yes, it can be better explained. Next is typical. There's something called representative elements or normal elements. So these are just the elements of group 1, 2, 3, 13, 14, 15, 16, 17. So it's because they have 1, 2, 3, 4, 5, 6, 7 electrons in them. When you go to the other groups, it gets a little bit more complicated. And then, yes, group 18 elements are also known as group 0 element. And then, and then are two other important, we have to, two other important is, groups of elements is lanthanides, which are um, element number 57 to element number 50, 50, sorry, we start from the element number 57 and then proceeds till number 57 plus 14 elements, which is 71. Yes. And then the actinide series starts from 89, and then they proceed till 89 plus 14, which is 100. Yeah. So these elements, the lanthanide series belongs to the group 3 6 period because they have 6 shells and 3 valence electrons, and it's due to something called, I think we have discussed in the last class only. So if you want to know it, go and see the out of syllabus class also. The electrons uh, of the previous shells are not complete, but valence shell is complete, which gives them same number of both same number of valence shells as well as same number of valence electrons, and we cannot fit them over there. And then the other third period elements, basically third period elements, they like basically there's some sodium, magnesium, aluminum, so they're all like they're probably some aggregates of all the properties of their groups. So they are just known as typical elements, or any group which we talk about. For example, uh, halogens can be summarized to like chlorine has a similar property to little bit similar properties to iodine as well as chlorine, but fluorine might have a more different properties to iodine when compared to chlorine. So that's why they're known as typical elements. That's one way to think about it. And yes, that's all we have to discuss about the periodic table. Now we can get into the periodic properties.